Good afternoon, and I hope you're all enjoying this year's FHIR conference. I'm Joni Harper of Canada Health Employee, and this afternoon, it is my pleasure to introduce Vasilii Kupriakov, who will be presenting about SQL on FHIR v2. Vasilii is a tech leader at Health Samurai, where he is implementing SQL on FHIR to the search and storage layer of their FHIR++ platform, Aidbox. Vasilii will take questions at the end, but please put questions in the Q&A section throughout the presentation. Vasilii, over to you.
Thank you. Hello, and first, what is SQL on FHIR? First of all, SQL on FHIR is an amazing working group which consists of people from many organizations who are involved in creating SQL on FHIR, the standard. Our goal is to create a bridge between the world of FHIR data and the world of databases, because database ecosystem is very mature, and we can benefit if we learn how to use it in the best way. And one of the aspects, the aspect which we are focused on now, is how to flatten FHIR data. We see that more and more data is aggregated in FHIR. And next step is start doing some analytics on top of this data. But analytics on FHIR is hard because FHIR data is deeply nested, and some resources could be arbitrarily nested. From our experience, people already make flat views from their FHIR data when they need to do some analysis to get insights from data. And we want to consolidate our efforts and create a standard to provide general approach how to work with FHIR data in relational databases. We believe that this will benefit community in many ways. One of the ways is it can allow us to decouple different use cases for this data. For example, some government organization can use commercial tooling to create the resources, view definitions, and SQL queries and distributes them. And then some hospital uses, for example, open source tools to run these queries and send the reports back to the government organization. And since it will be a standard, it will allow people to create good tooling for SQL on FHIR, because it's much easier when you have one thing like SQL on FHIR to build than when you need to build your tool to support every possible FHIR implementation in the world. And the last point, we can provide some library of useful definitions, so you will not need to invent how to flatten data for your use case yourself, but you can just get ready to use query and use it on your data. So there is already SQL. Why are we building SQL on FHIR? Because we want to leverage SQL ecosystem, which has existed for decades, and it has many great tools like Power BI for business intelligence, columnar stores for analytical queries, transactional databases, visualization tools, and many, many others. Next thing is FHIR search capabilities, for example. They're not very good at aggregating queries, and SQL was basically built for this. And the greatest of them all is SQL is a very, very widespread languages, and basically everyone knows it. So the core of SQL on FHIR is ViewDefinition Resource. This resource specifies how do we flatten our FHIR data to get just nice flat rows. Of course, we cannot come up with some very generic model which can be applied to every possible use case because of these difficulties in the design of FHIR data. But when we know our use case, we can build a flat representation which allows us to extract some useful pieces of information from this data for our use case. And to build SQL on FHIR, we leverage FHIRPath language. This is a language designed by FHIR, and it extracts data from resource. It already is used by FHIR. For example, in structure definitions, it is used to make constraints on resources. And in search parameters, it is used to define which pieces of resource we use for searching. So here you can see on the left some example patient resource. In the middle, FHIRPath expression, which extracts first given name. So FHIRPath expression can basically consist of parts of paths to your field and some functions like first. Result of FHIRPath expression is always an array. So to get only one element, we need to call first to leave only the first element of this array. And there is one simple next step. We can just write FHIRPath expression and column name, and it's basically what does ViewDefinition do in its simplest form. So you can see here select expression, which has alias, which names the column, and path, which is FHIRPath expression. And additional important properties of the ViewDefinition resource is resource, which defines resource type. So here it is patient, and name. This is the database friendly name. So engines will create you a table or view or materialized view with this name. And to show you picture which shows everything, here on the left there is patient resource, in the middle you see FHIRPath expressions, in the bottom there is ViewDefinition resource, and on the right the row which results from applying this ViewDefinition to the resource on the left. So here we extract name and by pass name given first, and we extract date of birth, call it DOB, and extract it by path birth date. Let's jump to Aidbox to play with SQL on FHIR interactively. And here we can see just some results which we get from applying SQL on FHIR ViewDefinition on synthetic data for 100 patients and related resources. For example, we can add one column, maybe it will be code, and when we want to add something, we need to start, for example, with alias, and it will be name of our new column. So we can say it with code, for example, or SNOMED code. And next is FHIRPath expression, and here we need to specify the expression. So it will be code, and FHIRPath SQL on FHIR engine in Aidbox is quite permissive, so you can see entire JSON contents, and we need to extract coding code. So we can just write our path coding dot code. And when we run, we see a flat representation of data we are interested in this resource. So we see SNOMED codes for condition resources. And next, I want to show you how just a few very simple view definitions can help you to create some dashboards very easily. So we will create, we have created these dashboards using 4 SQL on FHIR view definitions in less than half an hour. So basically, the greatest part of SQL on FHIR is you can write some simple view definitions, and then you can use very mature and great tools to do something you need to do very efficiently. So view definitions which we will create here will be one for patient, for location, for encounter, and for condition. So for patient, we need to specify, as in previous example, resource type in the resource field and the name of this view in the name field. And select expression here is pretty simple, but the interesting part is join expression. This is the extension of SQL on FHIR for FHIRPath language. We have created some a few functions for extension of FHIRPath to simplify common use cases for flat tables. So here is join expression, and basically when your query, this is name 0 given, extracts array, for example, it can be A, B, and we apply join with space, we will get array with only one element, which is A space B. Next view definition is very simple. It's for location. It just extracts name of the location and organization which manages this location. So this view is very, very simple. It doesn't even feature interesting FHIRPath expressions. And for encounter, there is a getID function. So recently in SQL on FHIR, this name for this function was changed for get reference key. And this function is very useful for joins. So this function is designed to be the key for join. So for example, you extract key in subject get ID patient, and you extract key in patient resources and join by these keys. Same here with location, so we will join patients and locations. And the last part is in FHIR, you often encounter some arrays, and often in SQL, you want to have one row per entry of this array. So, for example, if you want to build a relationship table. So, for example, if you have some observation with codes code 1 and code 2, you will want to have two rows, which is ID1 code 1 and ID1 code 2. And for each expression is designed especially for this use case. So when expression under for each, in this case it's coding, results in array, then view definition engine has to create a row for each entry of this array. And in nested select expression, we define parts of these elements which we need to put in columns. So for each coding, we extract code and put it under the code column, and we extract system and put it under the system column. And one more example is some analytical aggregate query. We will build a query which can which shows how many, which was the most frequent condition by age group. So we will build two simple SQL on FHIR views, and then one complex but straightforward SQL query, which will generate us this metric. So here we need to extract code, and here is where expression. Where expressions are part of FHIRPath language, and they filter data. So, for example, in coding, you can have codes from multiple code systems, and once you specify where expression with specific system, it will filter only codes from this particular code system. In our case, it's Nomad. And the second one which you need is patient ID. So because we will need to join patients to conditions. Next is just two properties which could be useful, but in our example, we will not use them. And when we create this view and run it, view definition, we have a flat table, and we can look at it and see that it's a nice flat table which can be used just with SQL and pretty straightforward. And then we just create a view definition for patient, just the same way as before. So we will get again a flat table, and then we can just build our SQL. So this is just plain SQL. It's straightforward to write. Yes, it's a bit large, but it is pretty simple. And in the result, we get our report with patient grouped by the age group, so 80 to 89, 70 to 79, and etc. And most frequent code and how many conditions with this code we have encountered. So basically, the most important and useful part of view definitions is you can create just very, very simple view definition resources, and it will allow you to leverage SQL ecosystem, write your SQL queries, and use tools built for SQL. Actually, SQL on FHIR is one of the few FHIR standards which has more than 3 implementations in this early stage. So now SQL on FHIR standard changes very rapidly, but we plan to stabilize this standard in less than 6 months. We believe that it's great because you will not have any vendor lock-in because you already have many implementations to choose from. And then, meanwhile, we plan to publish test reports and compatibility matrix on SQL on FHIR webpage, where you can just look which tests are there and which implementations exist for SQL on FHIR, and look how conformant are they. We develop SQL on FHIR in test-driven fashion, so we have a reference implementation, and this implementation we compare other implementations against this reference implementation, and we will make sure that reference implementation is correct. So you can just, if you want to create your implementation, you can use our tests and reference implementation to build it and simplify your implementation. And next, we want to create some standardized queries, some library of queries and definitions. So you will be able to just pick queries which are useful for you and apply them without need for inventing them. So we develop SQL on FHIR discuss SQL on FHIR in FHIR community chat. You can join these discussions and participate in developments. We have weekly Zoom meetings, and all our past recordings are on YouTube. We have implementation guide page with SQL on FHIR definition, and our reference implementation and tests are in GitHub repository. Test and implementation is our planned page with compatibility matrix and test viewer, and here will be a playground, so you can just open this page and run your queries and see how do they work with reference FHIRPath implementation. Thank you.
Thank you, Vasilii. We do have one question in the chat. What's the backend storing the actual FHIR data here? Is it just simply a FHIR server like Happy?
It could be a plain backend server. So, for example, reference implementation is in-memory implementation. We generate SQL queries. So Happy, for example, could generate their SQL queries, or they can materialize them into other tables. So there are many ways to build it. It depends on decisions of implementation.
Thank you. Next question is, a lot of FHIR servers currently store all resources in a single collection for flexibility as standards change, sometimes separating histories from current versions of resources. Do you expect SQL on FHIR to be used to separate resources into different tables in SQL back servers?
Could you please, so we expect, could you repeat from, do you expect?
Do you expect SQL on FHIR to be used to separate resources into different tables in SQL back servers?
Yes, you can. We expect that you will have multiple view definitions for the same resource. So on your use case, you will have view per table. And for history now, it's not a part of SQL on FHIR spec, but you can. It can be considered in future, I think.
Yeah. Still waiting for more questions. If you have a question, please put it in the Q&A. And I'll take one of the questions. So for explanation of benefit, it links parts of a resource using sequence. How do you work with that in SQL on FHIR?
In explanation of benefit, sequence is a positive int property. So you use it to link, you want to link multiple items to, for example, practitioners or other properties using this sequence property. So you can create multiple view definitions for each of these parts of explanation of benefit with segments, and it will have explanation of benefit ID with as a primary key and sequence ID, and you can use this composite key to extract your data and use it.
Yeah. And what is the behavior for each on an empty array?
For empty array, for each omits this row, but there is a for each or null expression, which includes rows when there is null.
Yeah. Do we have any more questions? Give it a maybe 10 or 15 seconds for somebody to type in. And if not, so nothing in feed loop. All right, then thank you, Vasilii, and I hope everyone enjoys the remainder of the conference. If you have a moment, there's a survey linked in the lobby chat regarding FHIR tooling. It's being used by you and your organization. It's a single question. We do plan to share the results to all participants, but if you could fill out that one question, we would really appreciate it. And have a good rest of your day.
Have a good day.